Welcome to the Joe and Friend Show. Today we have some special guests from Meroxa. If you remember Meroxa, we had Devaris from Meroxa on a couple months ago. This time we're going to be talking about Conduit, this new awesome product they came out with. Can't wait for them to talk about it. We have Ali and Lovro joining us on the show. So what's up, guys? How's it going?
Hey, how's it going? Thanks for having us.
Of course, anytime. Hey. So, yeah, tell me about this Conduit. How I heard about this was Devaris sends me a text late at night saying, "Yo, you got to check this out. It seems pretty cool." Yeah, tell me about this. What is Conduit?
Yeah, so Conduit is our open source data integration product. You can find it on GitHub. You can go to conduit.io. I assume we'll share links to that. But essentially, it's our alternative to Kafka Connect, that kind of functionality where you spin it up, you configure some connectors, and it'll pull data from one place and ship it to the other.
Interesting. What problem does this solve? Isn't Kafka Connect like awesome enough for everybody?
Yeah, Kafka Connect has a lot going for it. It's been around for a while, obviously part of the Apache project, so relatively mature. But we've had a fair bit of experience, or I personally have had a lot of experience running Kafka Connect at scale, and experienced many of the shortcomings and some of the issues around running that. And so pretty early on in our sort of Meroxa life, we came to the realization that we need to build something ourselves, make it a little bit more suited for what we're doing. And really, it's sort of taking the laundry list of issues and shortcomings with Kafka Connect and trying to tackle each one. And so, yeah, that's basically what we set out to build a better Kafka Connect that's better suited for our use case.
Interesting. What are those use cases?
So Conduit was initially designed to run on the platform. So the Meroxa data platform, that's our main commercial offering. And it basically enables software engineers everywhere to build and deploy sort of data applications, data products that take data from a particular resource, transform that data, and ship it to another one in the format that's required. And so Conduit itself is really focused purely on that data integration, data movement play, similar to Kafka Connect. And so, yeah, it's a very focused, it's a very, the idea of the small sharp tool approach where it really just does that one thing and hopefully excels at that.
That's really interesting. I mean, you mentioned something very thing that caught my attention was that this is focused on developers. I mean, not data engineers, or how would you distinguish these? What's a developer in your case?
Yeah, so the position that sort of Meroxa as a whole takes as a commercial entity, as a company, we definitely believe that the sweet spot that we're trying to target and the target audience we're trying to target is really the software engineer, right? I think data engineers are well catered for in terms of the specific tools that they want to use. More sophisticated things, a lot more customizability, maybe a lot more mature, but they're kind of well catered for already in terms of Airflow and Spark and all these various tools. Our focus is much more on the software engineer. The goal for us is to really empower people who are building applications in general, web applications, microservices, that kind of thing. Enable them to build out the data products that they need in order to do their jobs, in order to create value for their businesses, address certain pain points, solve problems. And so that's really the focus that we're taking. Right now, we're very much focused on building out that foundation. And so if you look at the data platform right now, it's mostly about data movement and data integration. And similarly, Conduit is squarely focused on that, right? It's the foundational piece that makes it very easy to take data from one place and put it into something another place in the right format.
Interesting. Yeah, this is something I think sort of along the same time that I found out about Conduit. I was thinking a lot about sort of where the stack should reside. Where does the app fit into all this? Where do developers fit
Mm.
into all this? Because I mean, if you think about a lot of the issues that kind of plague maybe the modern data stack or just data stacks in general, they tend to have, you're always a downstream recipient of everything, right? So data quality tools right now, they tend to focus on things at the data warehouse layer, but that's after it's been generated from an app typically, and it's kind of like, well, it seems kind of out of order a bit. I don't know if you had the same impression with sort of where the data stack, how it currently works.
Yeah, for sure. I think it seems sort of counterintuitive that the industry as a whole has kind of moved towards this idea of this very big separation between the things that are creating the data and consuming the data, and the things that are sort of transporting it and manipulating it and monitoring it and that kind of stuff. It seems like there's more and more distance between them, and that seems totally counterintuitive. If the app itself is the thing that's producing the data, why do you want to put so much distance between the other components that manipulate it and monitor it, right? And so our goal, and some of the things that we're working on and hope to release in the future, are really focused on sort of collapsing that back down. One of the ideas that we kind of spoke about is the application is aware of these models. It knows what the data records look like fundamentally at the application level. But then you put this sort of big separation between them and push that schema down into, so you throw it over the wall, and someone else needs to deal with that and kind of manage that. And that seems very sort of strange to kind of accept that this is just the way things are done. And you're like, well, the data engineering team has that responsibility to kind of handle that.
That's interesting. Do we want to demo it? Let's check it out.
Yeah. I'd love to get Lovro to show us a demo of Conduit, and maybe we can talk a little bit more about some of the advantages over.
Let's talk about it.
Over other things.
Yeah, like I said, when I first saw this, I felt like it was confirming sort of a weird suspicion that I had that maybe we actually have things completely reversed in the data stack. It was one of those random, like, serendipitous moments where just looking at the quick demo, I was like, this actually makes a ton of sense. I'm surprised more people haven't done this before. I mean, before we do the demo, I mean, why do you think that's been? I mean, what do you think has been sort of the friction between dev and data? For example, like, it seems to be this dichotomy between like software engineers and data engineers. And right now, software engineers sort of like lob things over the wall. Data engineers just take what they're given and, build giant pyramids or something. So,
all right. I think, I think maybe it's one of these, tech is filled with cycles, right? And so you get this generalization followed by specialization. And I think we're on the wrong side of that sort of cycle at the moment, where tooling and services have gotten so hyper optimized for particular use cases that the expertise required to manage it and use it successfully has become so high that it necessarily requires someone whose sole focus is on that. If you look at streaming in particular, which is obviously an area that we're focused on, Kafka is pretty much the dominant force when it comes to streaming data, but it's not trivial to use. I think it introduces a lot of patterns that are unfamiliar to most software engineers, software developers. You have to concern yourself with ordering guarantees and delivery guarantees and sort of semantics around, is this at least once and exactly once, and other things like that. And dealing with partitions and order guarantees that are based on partitions. It introduces so much that I think it requires expertise in that. And
it really does.
Specific
even
areas.
simple things like RabbitMQ, I see tripping up software engineers. And that's just message queues. It's really
for
easy.
sure.
And I wouldn't say it's really easy. Actually, it's pretty hard. So
so if you take that into account, and that's just, we named two products, right? That's Kafka and Rabbit. A typical sort of tech stack might include Kafka and Rabbit, and maybe there's an analytics cluster, and you probably have some caching layer doing something. You have all these specific tools that you're trying to manipulate data around. And so I think it's too much of a burden to lump onto the software engineer. And that's really, what we're trying to address, right? Is if we make it trivial, if we make it so easy and so transparent, kind of abstract that away, then we can kind of collapse it back into the software engineer and say, all right, you can now build those data pipelines, you can build those stream processing things, because we've removed that sort of deep expertise requirement. And so now you can kind of lean on the tools that you know and that you love and you have decades of experience using, and someone else does the heavy lift and sort of the translation for you.
Mm-hmm. Somebody said, "Woo, demo." So yeah, let's fire this up.
All right.
Sure, I can share my screen and show you how it's done.
Screen shared. Go for it.
Okay, so this is Conduit. It's currently running already. It by default starts running an HTTP server on port 8080, and that's also the port where the UI is accessible. So if we navigate to the localhost 8080, that's what we get, our Conduit API UI. Sorry. And let's create a simple pipeline. Name it demo, and it's going to be just a very simple pipeline that reads from a file and writes to another file, just a demo pipeline. Okay, so file 1 will be a file source, but we have other sources as well, so you could read from a Postgres or Kafka or S3 bucket, right? Let's put it into demo file 1, or let's call it source, so it's even more visible. Demo source. Destination is going to be another file 2, file destination, demo file 2. And this is relative to the Conduit binary. So that's why it's a very demo kind of scenario, because obviously Conduit doesn't access, for example, files on your host if you're running it on a remote host, right?
Mm-hmm.
But yeah, let's run it. So once we start running the pipeline, Conduit starts listening to. Let me just navigate out so we don't have this logs. Conduit is now listening to the file in demo, still file 1. The file 1 doesn't exist yet, but it already starts listening to it. So if it is created, it will start listening to it and start forwarding everything to file 2. And what I'm going to do here is I'm going to tail file 2, so we see whatever is written in here. And now I'm going to echo demo into file 1. And it, of course, didn't work.
I think you named it source.
Oh, did I? Yeah, you're right. Source. That's it.
There you go.
The other one is file 2. Makes sense. Thank you for that, for saving me.
No problem.
Yeah, and now I have a script, for example, mgen, which just generates, a number of lines. I'm going to pipe this into the file. So you see that basically once it's written into the file, it just instantly appears on the other side, right? So we are listening to it and instantly, in real time, just forwarding the changes to the destination. And let's make it 500,000. Then you see that it's basically scrolling through the file and forwarding records one by one, right? I'll stop listening to this because then it's much faster, because now I want to show you that we also have a Grafana dashboard where you can observe what's happening in Conduit, right? We are exposing a metrics endpoint where you can, this is basically a Prometheus style metrics, which you can, point Prometheus towards and gather the metrics, right? So basically we can see how fast it's going. Right now we are transmitting records, 10,000 records per second. And that's, you have to include that my computer is right now sharing the screen and running StreamYard and stuff like this.
Yeah. I think the one of the most sort of significant things, like the demo seems pretty straightforward, but one of the things that we explicitly tried to address with Conduit is that writing connectors and testing connectors for Kafka Connect is inherently very hard because it requires so many other moving parts, right? So Kafka Connect alone is a service that requires basically 3 distributed systems. So Zookeeper, Kafka, and Kafka Connect itself. Whereas with Conduit, it's a single binary. So you could just download this small 30 megabyte binary, run it locally, and actually have effectively the same experience and be able to iterate really rapidly. And so, yeah, that's like one of the big wins for us. The other thing, making it play nice with modern DevOps. Lovro showed the Grafana dashboard that leverages the Prometheus exporter that's baked into it. And so every Conduit instance has that. And so if you use Prometheus in your infrastructure, if you're running on Kubernetes, you probably use something like Prometheus, if not Prometheus itself. And so it sort of exports native metrics. And so you can just plug it into your infrastructure and get those metrics immediately.
That's really cool. What goes on behind the scenes then?
What's going on behind the scenes?
Yeah.
With Conduit specifically?
Yeah.
Yeah. So Conduit is just a really small sort of Go server that we've built. It exposes an internal buffer. So when you create a connector between a source and a destination, it sort of buffers it locally, and then sort of ships it down the line. And so if you want to achieve that Kafka Connect like persistence, then you could basically go from like Postgres to Kafka and then Kafka to wherever, and you can introduce that persistence. But if your requirements are pretty modest or you're just developing, you can just go straight from Postgres to Postgres or file to file in this case, the demo, and it just sort of runs it locally. We support persistence for the configuration in the server into Postgres itself, so you can use Postgres as a database to support Conduit, or we write to a local database. We currently use Badger, and so it just stores it in the file system. So really, a lot of the design decisions were around making it very, very easy for software developers and software engineers to actually build out connectors, test it, and do that kind of stuff with Conduit. And so the external dependencies are very, very minimal, and that's by design. Yeah,
that's really interesting. So how would I guess software engineer try this out then? Do they have to go download a binary or what does that look like?
I can actually show you. So this is our repository here, the Conduit repository, and we actually provide releases. So you can go and find the latest release and download a binary for your operating system and your architecture. If you don't want to go through a binary, you can also go to the packages where we provide a Docker image. So you can also go through the Docker image. Or you can, of course, clone the repository and build it yourself.
Interesting.
Yeah, we released under the Apache 2 license, and so it's a permissive license. And the goal is for us to really we want to make it very clear to the community that this is a legitimate open source project. We actually want people to use it and contribute to it. We aren't going to try and sell Conduit. It's not it's not aligned with our sort of our thinking. We really want to grow the community around it and encourage people to use it and build connectors. And so we're trying to make it very, very friendly, sort of low barrier for entry to use and to operate, as well as to build for. We're going to be developing sort of mapping out our roadmap in public, and so in the open. And so you'll be able to see what issues we're working on, what's coming down the line. And so there are a couple of things that I think are pretty significant, like the connector SDK. That's something that we're going to be rolling out soon-ish, which will make it very easy for people to write connectors. Kafka Connect requires you to write connectors in Java. And so if you love Java, that's great. If you don't love Java, you're kind of out of luck. In our case, one of our early sort of design decisions was to leverage a gRPC-based interface for plugins and for connectors. And so you can actually write a connector in any language. As long as you implement the gRPC API, you can plug in whatever connector you want. And so for us, our native plugins are written in Go because Conduit itself is written in Go. But yeah, if you're a Python shop and you want to write a connector that serves your particular use case, you can totally write it in Python, implement the gRPC interface, and Conduit will happily use it.
Or if I'm a Java user, I could write it and
yeah, absolutely. There is a project for us to we're hopefully planning to release a Kafka Connect wrapper connector. And so if you're already using Kafka Connect, you can drop your existing connector into our wrapper, and Conduit will just use it. And so that gives you a nice, clean sort of migration path to move away from Kafka Connect and use Conduit instead.
Interesting. Actually, Matt Sielmer, he has a question here. He was. He says, "Apologies if he was late to the start." And I have a chart already. But what was the aha circumstance that caused this project to be conceived?
So the aha moment for us was looking at usage of connectors on Kafka Connect. So to be clear, the Meroxa platform uses Kafka Connect right now, and we use a combination of Conduit and Kafka Connect. But the aha moment for us is looking at the resource usage per connector on Kafka Connect. It basically maps to be like the pathological worst case scenario for a managed service. Essentially, you get this long tail where you have a large number of customers that have a large number of connectors doing very little traffic. And then you have a very small number of customers with a very small number of connectors that are doing a huge amount of traffic. And so when you look at sort of packing density and the economics behind running as a managed service, that is the worst case scenario. So you have a lot of resource usage, specifically like memory. And so when we started looking at other alternatives, by the very fact that Kafka Connect runs on the JVM, you're sort of paying this upfront memory usage tax. And so when we sort of explore that a little bit, per database connector running on Kafka Connect, we saw memory usage of anywhere between 800 to a gigabyte of RAM. And then when we built the sort of equivalent spike in Go, we were seeing close to between 8 and 10 megabytes of RAM. And so that enables us to really increase the packing density massively, which basically gives us the option to either be more profitable per connector or reduce our costs significantly. And so that was really like the aha moment for, okay, we're planning to build a managed service. How can we make this sort of feasible? And then obviously my experience running Kafka Connect at scale, I think anyone who runs Kafka Connect at scale has their horror stories and will kind of be intimately familiar with some of the sharp edges there. And so that was the opportunity for us to really go, okay, if we were to build something new from scratch, what would we build and what would it look like and what kind of functionality would we want? And so Conduit is really the result of that. It's sort of our wish list of, if we created something like Kafka Connect from scratch, what would it be like?
Interesting. I like it a lot.
Yeah, I think it introduces a lot of interesting possibilities that we hadn't even really considered before. The fact that it's a single binary, it's very lightweight, means that theoretically you could run it on your own system, right? Say, I know it's hard to believe, but many people still use Excel a lot for many things, like everything, And so it's entirely possible to have an Excel connector that enables you to sort of keep an Excel file locally in sync with a Postgres database in the cloud, right? You just run the binary, the Conduit binary, you point at your Excel file, and it'll look for changes and push those up there. And so that's nearly impossible to do with Kafka Connect. Like, it's an unreasonable expectation to have, some person sitting at their laptop somewhere say, all right, like, please deploy Kafka and Kafka Connect on your local machine because we want to pull this up. But with Conduit, it's totally achievable. It's a really tiny, low resource usage tool. And so you could do that. You could actually cross-compile it and run it on like a Raspberry Pi and have it read sensor data from things. So I think the architectural choice of picking something that's compiled and sort of lightweight actually opens up a lot of additional use cases that we didn't really necessarily plan for initially, but kind of opens it up for us now.
Interesting. Matt has another question here. I know you said roadmap is pending, but what is the hairy problem you're heading to solving? Is it more about getting back to efficient products, play in the middle of more complex flows, etc.?
I think the hairy problem we're heading to solve is really about sort of operator ease and sort of developer velocity. It's really about enabling connector developers to build and test connectors more efficiently, more quickly. And that obviously feeds into sort of the operation side of being able to support more additional use cases and kind of addressing the data connectivity part in a more modern DevOps style. So, one of the things that we said is, Conduit's written in Go, so it's very resource efficient. That basically translates into direct dollars saved. It plays nice with modern DevOps, so you can plug in your existing, Prometheus cluster and monitor that kind of stuff. So yeah, I think that's kind of the two sides of it. It also plays very nicely with our the broader Meroxa ecosystem, right? Conduit is our open source tool, but it's part of the we use it on the Meroxa platform, and Meroxa as a whole is trying to solve as I mentioned, the software engineering, sort of data engineering for software engineers, I guess would be a way to put it.
That's a good point too. I'm going to riff on that a bit. Right now, I on one hand, I understand why there are sort of the walls put up between software engineering and data engineering. And in a lot of cases, though, especially when it comes to ingestion, I think these are a bit artificial, right? Like software engineers generate data from source systems. Data engineer then has to find a way to connect to these things. So typically, this is a bit of a pain in the ass. There's no shortage of options these days, but it kind of fails to address, I think, a lot of the upstream problems that occur where data is generated these source systems. Then there's a lot of kind of middle stuff that happens. It goes to a database, and it's extracted, put into a data warehouse, et cetera, et cetera. So do you see a situation where something like you could just use Conduit to just pipe data directly into, say, a data warehouse or data lake, and just sort of bypass the so the ELT paradigm that we have now?
Extra hops.
Yep.
Yeah, I think that's the goal, right? If we make it easy enough for everyone to understand and everyone to deploy and sort of manage, then yeah, I think that's totally where we're headed. Again, to empower sort of software engineers to address their own problems and not have to rely on a separate engineering team to kind of figure out what to do there. I think I'd love to kind of throw it over to Lovro and ask him to talk a little bit about some of the things that are coming down, like on our roadmap that kind of address this use case.
Yeah. So the first thing, the thing that we're currently working on is the Conduit plugin, which Ali already mentioned a bit. So we are creating a Conduit plugin interface, which is kind of revamped. We already changed it, and right now it's going to be written in a way that we can actually include plugins into Conduit, so we can ship them built into the plugin into the Conduit binary. So this means that you'll get a single binary where you can get a bunch of built-in plugins already shipped with it. Another thing is that we are going to extract it into a separate repository so that the plugin interface is going to be defined separately, and you'll be able to generate it for other languages. So it's not going to be only for Go. That's the SDK that we provide, but you'll be able to generate the code for JavaScript or Java or any other language that you want to write the connector in, right? So that's the first thing. Other things that are still in the pipeline is, for example, the JavaScript transform that we're working on. That's going to enable you to write the transform in JavaScript, so you don't have to rely on some built-in transforms that we provide already and might not fit your use case completely, right? But you can write it yourself and transform the record as it's going through the pipeline, so that it comes out on the other side as you want it, right? So that kind of ties into the use case that you were talking about. You don't have to go through other tools or stuff like this. You can change the record as it's going through the pipeline. You don't have to persist it anywhere because you just need it on the destination, right?
Yeah.
And it's just going on the fly, basically.
Interesting. Data quality is a really big topic right now. How would you address potential data quality issues in something like Conduit, where you're just writing directly to a destination?
I think right now that's not something that we address particularly well. I don't think we have anything specifically handling it. Transforms would get you some of the way. You could write some constraints within the transform that says it must follow this particular format. These fields should look like this. But that's definitely something that we think about a lot. I don't think maybe Conduit is not even the right tool for that specific thing. But I think integration with existing partner systems that do that kind of thing, I think is where we'd like to go. That's definitely what I'm thinking about in terms of sort of the Meroxa data platform, is really lean on existing tools that do that. But our goal is to make it easy for people to use them, right? I think there are a lot of tools out there that expect a certain amount of setup or require a certain amount of setup to sort of wire them into your infrastructure. And if we can make it, trivial, where you just select from a group of partners that we work with, and we'll just do the wiring up for you, I think that's really what I'd love to see us get to.
That's really cool. One thing that comes to mind is reverse ETL. Maybe so.
I have, I don't know if this is you're baiting me into a discussion, but I have some strong opinions about reverse ETL.
Nothing like that. No. But it seemed like if you have one pipe going somewhere, you have a pipe kind of going out. Maybe.
Yeah.
I don't know if you have any thoughts on that. So.
Yeah, I have some strong opinions about reverse ETL, and I'm sure Tavares can relay some interesting stories about that. I almost feel like reverse ETL is it's obviously very big, and there's a ton of demand for it. But I think if you look at the actual sort of problem that's being solved by reverse ETL, or what the intention is, typically it's my operational databases or some sort of operational components are producing data. I'm trying to derive some insight that potentially combines a number of these things and produces some result. And then I want to take that insight and inject it back into my operational thing so that I can make business decisions on it. And so what we've ended up with is this very elaborate loop that takes data from things that are very close to the application, ships it really, really far away from the application into like a data warehouse, does some sophisticated analysis, and then ships it all the way back to where it initially was. And so I think this is the solution that we've come up with because of the tooling that we have. But I think something like Conduit, Conduit with transforms and things that we're building on the Meroxa platform really aim to address that particular use case. If everyone had a very easy way to take data out of their operational database, combine it with a bunch of other things, derive the insight immediately, and in real time inject it back into their operational database so that they can make business decisions on, then you would save yourself this super long trip through the data warehouse and back. And so I think there's always going to be some use cases where that's necessary because of sheer data volume or whatever it is. But I think there are a ton of use cases that can be addressed in a much more sort of performant way by just having something that can easily pull data from your operational database, run that stream processing or that derive those insights immediately and push them back into your operational data store. I think Conduit is one part of that solution. We've been working on some other things around enabling software engineers to build data products and data apps. And one of those things basically allows you to run sort of arbitrary code and execute sort of more sophisticated functionality, which could be combine data from multiple sources, enrich it with a third-party API, and then inject it back into your operational database. And so I think reverse ETL is a very elaborate, sort of long-winded solution for a specific problem that I think we can address better, hopefully.
Yeah, this is fascinating too. Like I said, it's interesting just the timing of it because it was something that's been on my mind a lot. Just as I've been thinking a lot about the space and writing this book on data engineering, it's occurred to me like, well, like why don't we just handle more things at the application layer? Like why do we need a lot of these hops and steps, hops to put them right? It just seems because I think we're trying to take technologies that have been used for a long time, like the data warehouse, for example, and just trying to shoehorn things into that. And that's kind of the destination. Like I remember I saw this tweet recently from Sarah Catanzaro, where she's kind of like, data engineers who want to, I'm going to probably butcher it, but people who want to use like a data warehouse for the, basically the application database. Don't need to think twice about transaction handling or reading 25 years of Postgres research and development. So,
I think, it's definitely it's bizarre that we've gotten ourselves into this state, but I think a lot of it is to do with the tooling that's available. So sort of batch and ELT has been around for decades, and the tooling is bulletproof at this point, right?
It's good.
It's super stable. It's super well understood. Everyone knows how to use it. But the performance constraints of that aren't suitable for operational things. Like you can't make business decisions if it takes a batch job 4 hours to run before I can derive that insight, which I need to respond to the customer in real time. And then if you look at, okay, let's try to do this in real time, the tooling is super immature or very, very complex. If you want to do this today, you're going to, necessarily looking at like Kafka and Kafka streams. So you're going to be writing some very sophisticated sort of Java code that understands windowing and introduces all these concepts that you're not really familiar with. And then you have to deal with records that are late and out of order and all these other things. And so I think the tooling is not there to really enable that to happen. And so we fall back on tools that we do understand and is available. And so you end up with this, all these extra hops and reverse ETL, right? Because you're going batch all the way to the data warehouse. Totally understand that part. And batch all the way back into the operational database. Totally understand that. But that's kind of the trade-off.
So it seems like, from what I'm reading into this, maybe I'm reading it wrong, but it seems like maybe batch in some cases doesn't need to be there. Maybe batch is sort of an artifact of maybe a time gone by. I don't know.
I mean, that's squarely where we stand, right?
Yeah.
From day one, Meroxa has been focused on real time,
Yep.
and that's why we started with real time by default. Is really the thing that we're pushing for. I think that takes people generally have some objections with real time because traditionally it's been very hard to deal with, like for the reasons that I mentioned, right? It introduces a lot of new patterns and new paradigms that people aren't necessarily familiar with. But our goal is really to make that easier. If we can build tooling that makes it as easy or as familiar as batch, as traditional ETL or ELT, depending on what you want to do, then we can kind of smooth out those surfaces and sharp edges and make it so that, I might as well use real time because it's not really that much harder for me. And I'm getting this ability to now just derive the insights and push it straight into my operational data store without having to go through all these extra hops and reverse ETL it back into.
Interesting. So in this new paradigm that we're talking about, how does a software engineer need to rethink their stack?
So this, I'd love to talk a little bit about some of the things that we're working on right now. And I think for us, our goal is to try to, collapse that stack, really to remove all of the specific knowledge or the expertise required in the data engineering world and make that sort of the end results available to software engineers. And so our hope is that the software engineer doesn't have to rethink their stack, right? If we can expose tooling that basically makes streams look like an array or a slice, sort of makes the Kafka topic or whatever it is look like a finite list, and they can write functions and stream processing based on the fact that it looks like something they're familiar with. They're using the tools that they're familiar with, the language that they're familiar with, the packages that they're familiar with. Then we can sort of remove that and abstract that away. And so that's really what we're trying to build. And so the thing that we've been working on, this data framework thing that we've been working on, is really about that. It's collapsing that into the software engineer's world and making it so that the software engineer can just use familiar things, familiar patterns, familiar workflows. You build an application in Java in your case, or Python or Go, whatever it is, and we translate that into the various components that are needed to create this sort of modern streaming infrastructure.
Interesting. Matt's got another question here. Good questions, Matt. Long-time listener. He asked, which industry use cases are you working with where real-time is the default?
Well, in our case, real-time is the default for every use case. Like we don't necessarily have a way to run that isn't real-time. And that's just the way that the tooling is constructed right now and the way the Meroxa data platform works. So yeah, every use case we deal with is in real time. That doesn't necessarily mean, the use case requires, like sub-second or sub-millisecond latency. It just happens to be our infrastructure is based on Kafka, and that's what we do. And so even if your tolerances are much broader and you're okay with latency, you'd still run on top of Kafka, and we would provide the tooling on top of that. And so underlying infrastructure is always real time for us. And so, yeah, that's generally the use case. So if you look at like data migration or data syncing, you might have geo-distributed Postgres databases or something like that. Then that's a real-time use case where my application is talking to a database in the US. and I have another application that's talking to a database in the EU, and for whatever data localized data requirements require you to have the split database, then you could do bidirectional syncing of certain tables, right? And you want that to be in real time, so that a change that happens in the US is replicated into the EU. That's just an example.
Let me flip the question on its head, and it's sort of, I think, kind of zooming out and generalizing this question. Are there ever use cases where you would not want to use real time as a default, or real time is like a really bad idea?
I think there are some use cases. Well, I think there are a few use cases where real time is not necessary, and so you're paying a additional sort of complexity and maybe resource tax that you don't necessarily have to pay. I also think if you're processing historical data, like terabytes and terabytes of historical data, then real time is probably again, you're paying this sort of complexity tax or resource tax for not really that much of an advantage. But I sort of believe that there isn't no use case exists that cannot be solved in real time. I just think many times it just doesn't make sense, or it's just not worth it. But real time is sort of the superset, I think.
Yeah, like I tend to subscribe to Flink's philosophy, where batch is a special case, so it's a subset of streaming.
Yeah,
because that's just the nature of bounded and unbounded data. That's kind of how it is. Bounded is just an artificial case, but it's in a lot of cases it's very convenient though, and there's a reason it's been used because it's convenient. So.
Yeah, it's definitely much easier to reason about and sort of work in a sort of a finite non-continuous stream of data. So I think if you're always working in real time, you're necessarily taking on this additional complexity. But that's what we're doing, right? We're taking on this additional complexity so that customers are kind of sort of blocked from having to deal with that themselves.
Yeah, thank you for that. So, actually, got a question from Taryn Foxworth from YouTube. Technically, how are you capturing the changes to the sources? What if the source has no streaming mechanism for capturing changes?
Lovro, do you want to take that?
Sure. So how we're capturing changes. So if it's possible, right, we're doing CDC. So we're capturing data changes basically, right? Sorry. So for example, in the Postgres, in the case of a Postgres database, we would latch on to the logical replication, right? And we would listen to any changes that are coming in, create records for them, and send them to Conduit. If that's not possible, we are going back to long polling, right? So that's the other alternative. We're trying to do the best thing that we can. If it's possible, we're doing the best thing. If not, we're doing long polling.
Hopefully, that answers the question.
I think the interesting thing here is because we're writing connectors, and sort of Conduit itself doesn't really care or mind what's producing the data that's being fed through the pipeline to the other destinations. That you could create a connector that works in any particular way that makes sense for you, right? So we actually have a data generation connector. So it doesn't pull data from anywhere. It's actually producing it locally and pushing it down the line. And so if you're connecting it to something that doesn't inherently have streaming data or changes, or it doesn't make sense for it, that's still okay, because you write the logic, you decide how you want it to behave and what it should produce, and the connector will do it, and Conduit will happily accept whatever it is and pass it down the line.
Interesting. Hopefully that answers your question. Taryn actually wrote yes, so good answer. So that's awesome. Well, cool. How would people find out more about Conduit then, and more about Meroxa as well?
So Conduit has its own website. It's conduit.io, and so you can go and read about the product and the tool and about the other connectors, and it links to documentation and all that stuff. It's obviously on GitHub, so we have a separate GitHub organization for Conduit. So it's also Conduit.io, one word. And so you can go there and look at the repo and the other projects. And like I said, we're coding in the open, and so you can see the issues and what we're working on right now. And you can interact with our community, and we use GitHub discussions. So if you have ideas or connector requests, you can mention them there, and the team will kind of jump on that. And then Meroxa is meroxa.com. So you can go there for everything related to Meroxa.
Awesome. Yeah, I feel like this is one of those conversations that might be looked back on in about a year or two, where it was kind of it's subtle. Like if you look at it on the surface, like what's here?
Yeah.
You dig between the you dig underneath it just a bit though, and I what I feel what is happening is there's sort of an inversion going on with the data engineering, and we're sort of flipping the funnel on its head in a way.
Yeah.
You know, and like I said, I'm writing this book on data engineering, and I've been thinking of ways. Okay, so like what makes data engineering obsolete? Right.
Yeah.
It's stuff like this where you're basically just removing the cycles, you know, just chipping away at the what I call the data engineering life cycle and just saying, well, what does this need to be here? Or can software engineers do it? Like I
Yeah.
have this crazy idea. Basically, in 10 years, there won't be any distinction between software engineers, data engineers, and ML engineers. Even like it's all going to be kind of the same thing because the workflows are.
We definitely believe the same, and that's what we're working towards.
Yeah. So the next edition of my book will be called The Fundamentals of Software Engineering.
Where did data engineering go?
Yeah, exactly. Yeah. No, I mean, but I think it's interesting though. I mean, you got to be willing to kill, you know, your own in this regard, right? Because I think the thing in tech and data is nothing static, and so, you know, and even these notions of modern data stacks, I think are nice and noble, but at the same time, like things are changing very, very quickly. You know, things like Conduit, like I said, when I saw the the short video, I was like, okay, there's something here. This isn't just some like hello world thing. Dig between the surface. You basically just like removed a few lines of friction, and pretty big ones. So this is cool. I hope you guys continue, with this project. It's awesome. So
yeah, we will. I think one of the analogies that often comes to mind is, previously, the idea of the DBA existed, and that was a thing. And you had a team or a person dedicated to managing your database. And then sort of ORMs came along and kind of abstracted that away. And now software engineers deal with that sort of design to a certain degree. And so I feel like there's room for us to initiate a similar shift, right? If we can create the equivalent of that move for data engineering and roll that tooling into the software engineer, bring it a lot closer, then we can kind of make a similar shift in the industry.
For sure, because I feel like streaming is one of these areas too where it's not as baked as batch by any stretch of the imagination, right? Like I talk to people, like one thing that's been on my mind lately is data modeling for streaming data, right? So in batch, there's numerous methods. There's Kimball, Inman, Data Vault, yada, yada, yada. In streaming, I've talked to a lot of people who've built very major systems, and there's no consensus. In fact, the consensus is don't model your data, just assume it's correct at the source. And as much as I want to believe that that's a good answer, how many times have you seen wrong data come through? And so I think it's a good assumption. It could be a dangerous one depending on who's writing the data. So
right. Yeah, and it's only going to get harder as more sources, more data being piped into your streams, and your sort of greater reliance on these streams having the right data in the right format and the quality being there. So yeah, it's only going to get worse before it gets better.
Before closing out, where do you think transformations live in this kind of new universe that you're imagining or building, I should say?
Yeah, I think so. In the scope of Conduit, we see them as being sort of a core part of allowing the users to make that sort of last minute tweak and getting it into the format that it needs. In the broader scope of Meroxa, I think transformations are really a central part to what we consider to be the data application or the data product. And so I think there's, at least from my point of view, it makes sense to have the data in the database is going to be in the format that it's in because that's needed by the application. The data format that you want going downstream for that extra flexibility, that's on you, right? That's part of the data product. And so I think the transformation or the data process, the data function at that point becomes super, super important. But I think with the ability to transform it in any particular way you want, we also need the tooling to monitor that and version it and address it, post transformation. And I think that's the part that's currently missing. I think it's very easy to transform data and drop fields and mask fields and add stuff. But then what happens downstream, right? You have this expectation that, the data format should be this particular way. And now I've changed it because my requirement has shifted. Well, now what? The pipeline's broken. I need to recover it. So I think there's an area there for evolution of data formats, and I think that's really underserved and not well addressed right now.
Yeah, for sure. I feel like stuff like DBT, I think it's a really good first step. But if you look back to even like just templating language of like Ruby on Rails apps like 12 years ago or more, it's basically the same kind of ORM stuff.
Right.
So,
yeah,
I'm fascinated by this field. We'll have to probably chat offline about some ideas. So,
yeah, for sure. Sounds good.
Yeah, awesome, guys. Well, it's good to have you on the show. Best of luck to Conduit, Conduit.io, Meroxa.com. Check it out. These guys are doing some really cool stuff. So thanks to the audience for the questions. And yeah, we'll chat soon. So
awesome. Thank you very much.
All right. Thanks. Bye-bye.